Hello, welcome to this new video for you. This video we are going to talk about the opening operation. As we have been seeing from the previous videos, we saw the erosion and dilation operation. So we are going to see how we can perform opening operation based in these two basic operations that we have studied before. In this slide, we are going to see what is the basic for opening operation. Fortunately for you, it's gonna be very easy because you have learned before what is the basic of opening, which is based in an erosion followed by a dilation. So we have here the mathematical equation that describes the opening operation. So we perform first an erosion and later we perform a dilation with the same structural element B. So let's analyze an example in this image we have here in this object A, and we are going to use as a structural element a ball, as we can see over here. So this is the image, and we have here the erosion operation, and we have here the final result of the erosion. As you can see, we have this is the basic concept that we learned before. We have an erosion in which this object is smaller than this one, but we perform later a dilation using the same structural element, the ball, and this is the final result what we have here down here. So I just want to highlight which are the characteristics, which are the features we can find after applying an opening operation. First, I just want to tell you it smoothes the contour of objects. So we can see how the contour of the objects are smooth by this operation. Also, this operation eliminates thin connections. So in this example, for example, we have this connection between this part of the object and this other part. We have the thin region that connects both sides, and we can see here how this region was eliminated. So opening performs an elimination of thin regions and also eliminates regions that do not contain the structural element. So on that way, we can see this final object is similar with this one, but we have contour objects smoothness, and we have thin regions eliminated, and we have different properties that we can use in several image processing applications. So for the exercise in MatLab, we have the same idea, the same two images we have been using in previous videos, and we have a similar description of the exercise. We are going to perform opening operation using an implemented function, and we are going to make a comparison with the inbuilt MATLAB function. Here in MATLAB, we can see that we keep the same structure of the previous codes, and we added some new two lines in which we have the function that performs the operation, the implemented function, and we have here the inbuilt function from MATLAB. So what is inside this implemented function? Nothing to be afraid of, nothing to be worried about, because we are just using the erosion function we implemented before and the dilation function. Okay, we just make sure that we are applying erosion first and then we apply a dilation operation. So just keep in mind, it's very important to remember that we need to use the same structural element. The same structural element we are going to use in erosion and in dilation. So if you change the structural element, it's not the same. We are not talking about an opening operation, okay? So finally, let's execute and see what we are going to see. Okay, and we have here the original image, and we have here the structural element, and we have here both results. As we can appreciate, both results are equal, and we can see how this how was performed first the erosion and then the dilation. Okay, we see how some thin connections were eliminated, how we keep some area, how was smooth on the contours. And if you're looking for see more details about this operation, I suggest you to use a bigger image with more detailed pixels in order to understand better. Okay, I hope you like this video. I'm hoping to see you again in the next video I'm going to be releasing about morphological operation. Okay, bye bye.